Almost everybody that is interested in mathematics knows the fact that the square root of 2 is irrational. But most people know the fact and not the proof. And so in today's video, I will be proving this fact with an algebraic proof and a geometric proof. So let's dive straight in.
But wait, what does it mean for a number to be irrational? Well, it means that the number in question cannot be described as a ratio a divided by b. And that is why it's called irrational, not a ratio. Anyway, with that out of the way, let's start with the algebraic proof. Let's assume that root 2 can be described as a ratio in the simplest form, a divided by b. Now this can be rearranged as 2 times b squared is equal to a squared. Now since the left-hand side is even, then the right-hand side must also be even, then implying that a is even, since if a squared is even, then a is even. Now since a is even, we can describe a is equal to 2c, thus implying that b squared is equal to 2 times c squared, meaning that b squared is even, and then also that b itself is even. Now this is a contradiction, since at the beginning we said that a divided by b was in simplest form, yet we can prove that a divided by b are both even, meaning that they are not in simplest form and can be both divided by 2, hence the contradiction. Well, what does this mean? Well, it means that the square root of 2 cannot be described as a ratio a divided by b, or the square root of 2 is irrational. Now on to the geometric proof. Let's, as we did the last one, assume that the square root of 2 can be described as the ratio a divided by b. This also means that a squared is equal to 2 times b squared, as we said before. Now we can look at this as literal squares, where the square with side length a is equal to 2 smaller squares with side lengths b. If we arrange the squares like this, the overlapping area right here must be equal to the missing area that was not filled in, meaning that the 2 smaller squares that weren't filled in are equal to the middle square that was overlapping. This implies that a and b are not in simplest form. Hence we have 2 smaller squares that have the same property as a and b. Hence a contradiction, and the square root of 2 is irrational. I hope you enjoyed these proofs, so thanks for watching and please subscribe if you enjoyed this content.